I'm the only one sitting inside of my house,
Oh
but
my.
yeah, I see people walking with footballs and stuff. So, but it's not as frequent. I would say that every 10 minutes I see 3-4 people just walking around.
All right, Ayush, thank you so much for that brief update. Over to Sonal,
Yeah,
because
yeah.
the audience may be looking forward to
Sure,
your
sir.
words of wisdom.
Sure, sir. Thank you so much. And Dr. Sonal Jain, would like to welcome Ayush panelists, other panelists, and all participants who are attending this webinar currently through our registrations, as well as this session is also live on Facebook. So I welcome you all. I take the privilege to introduce Dr. Ayush Bhandari in this distinguished lecture series session of JK Lakshmipat University. The title of the talk is Rat Race and Beyond, a personal perspective on education and career choices. Introduction of Ayush goes like he received his master's and PhD degrees from MIT. Thereafter, he joined the Imperial College, London as a faculty member in the engineering department in 2018. In 2019, he was appointed as the August Wilhelm Scheer visiting professor at the Department of Mathematics, Technical University of Munich. In his work, he prepares mathematical models and systems for novel digital sensing and imaging modalities. His research publication spans the midfield of applied mathematics, signal processing, optics, computer vision, and imaging. He has held research positions at EFFL Switzerland, CUHK Hong Kong, INRIA France, and NTU Singapore. He has also been a short-term visitor at the University of Cambridge, Technion, Max Planck Institute, Norbert Wiener Center, UMD, and University College London. He co-instructed the mathematical methods in imaging class at MIT and has been a tutorial speaker at various venues, including the ACM SIGGRAPH and the IEEE ICCV. I welcome you, Ayush, again, and audience is all yours. The webinar would go in an instruction mode initially, and at the end we will have a question answering.
Right, right. So thank you for having me. I just wanted to start by saying that so typically this kind of talk, as you can see from the title, it's a bit controversial for an academic to say that, but I would still go out and put myself, because I've done so many unconventional things throughout my educational years. So I would say that I'm used to more of an interactive session, because it's really for the others to benefit. But the slides here are just to support my case, because it's online, and if I don't even have slides, I don't really know who am I speaking to. At least with slides, I can speak to myself. So, all right. So I would start like this. So as you can see, the title, Rat Race and Beyond, typically it's no big news that what rat race is, but I'm approaching this topic more from the perspective of education, because I decided to choose a path in that area. But it's not necessarily just education. In fact, when I was thinking of what to do after my PhD, I spoke about my options to different people. And I met a venture capitalist from the Khosla Ventures, and just wanted to get an idea of what it means to, to have an alternative career, maybe in the Bay Area and so on. And this said that they don't see a big difference between being an academic, because it's the same as doing a startup. You are all by yourself. So, every place has a rat race. And even though I talk about education, but it's not education, you can really map it back to what you do. And I hope you can benefit. So I would start with a little disclaimer, because typically these things are not a public event, but I just want to say that these are not the views of any of the organizations I'm affiliated with. It's a purely personal point of view. All right. So in December 2016, as you can see this picture, I was living in Boston, and I had subscribed to the New Yorker. And this cartoon is very interesting. You see a man waiting for a train. Clearly he's headed to a job, because he has a coffee, and you can also see his bag. So he must be on way to job. But then you also see a little rat over there, just dressed like the man. And what's interesting is that as the man is preparing to go to a job, so is the rat. So clearly this is the widespread notion of rat race in our lives. Rat race means, things that everybody does without thinking. And if they don't, they think that they're missing out on something. So the question is, do best things in life happen that way? And we know that they don't. But then what is the main divide? Like, why is it that we know that life doesn't work that way, and still we sort of approach life that way? So the reason I decided to speak about this is because I think I took a few steps which were completely opposite to the rat race phenomena. So maybe some people, just by seeing what I did differently, maybe they can also benefit from trying similar approaches, but not necessarily just copying them, because as you all know that copying somebody won't really lead to anything. It's just like a guideline or a structure. So how I've structured this talk is I plan to speak for about 45 minutes. I want to say a little bit about my own introductory background, because if you don't know me about my own life, then there's very little to know about what is my way of rat race or not being in a rat race. I will give a few short stories about where I grew up, what I saw, what was rat race, what I tried to do, what I tried not to do. And then finally, I would like to summarize things with take-home lessons, which is that what I see is like a general sort of way of thinking, and what kind of lessons can we learn, or what kind of things we can immediately reproduce to make our lives better. And then, of course, I'm more interested in the concluding remarks or question and answers, because I think that's the heart of this whole talk, not necessarily what I do or what I see. So I would start with a little bit of introductory background. So as you already know, I received my doctorate in 2018. Then I moved to London, and academically, I've been around in quite a few places. So typically I say this because if you have any questions about what places to choose or how to choose, I mean, I have quite a bit of experience to say what is probably good. So in terms of, so I like to think of life as a multidimensional sort of thing. So I've lived in more than 7 countries, and I think that is what gives me more experience to think and see about, say about things, rather than really just being in academia. So as you can see that I've lived in different parts, mostly in Europe, but I also took some breaks. For example, there were times when I was intensely tired and I wanted to just take a year off, just thinking what to do. Typically people don't do that, but I think it worked out quite well for me. So we will come back to that. So what do I do in my professional life? So as you know that we are all surrounded by sensors like hardware. Right now I have this interesting microphone which suppresses noise in the background, but typically people who are using cell phones and using Instagram, they have a camera. So you have a hardware, which is the camera. You take a photo, and then you use the Instagram filter, which is basically an algorithm. And then the algorithm spits out some data, and that's the data you use. And that's a traditional view of looking at things. So you capture, and then you process, and then you make sense out of it. And there are many classical applications that work on this, which impact our daily life. For instance, the moment you open a JPEG image, it's called JPEG because it's a compression algorithm which compresses the large image into a small one, and then it allows you to open, and so on. And in most of these cases, what is happening is that you take the information, then you make sense of it. But what has happened, which has been a bit of revolution in the last 10 years or 20 years, I would say, is that there has been a different way of thought, which is that you don't just capture and then process, but you capture in a way that you make more sense out of what you have captured. And MRI is a great example. If you look at an MRI scan, you don't really make sense of the MRI data when it comes out. What you do is you churn some data with algorithms, and then you make sense out of it. So in my work, what I'm trying to do is that I'm broadly trying to do something similar, but at a different scale. So just to give you an idea of what that means is, take a look at this slide. So typically, I like to show this slide to the audiences, and I like to ask them, what do they see on the left and what do they see on the right? Now, everybody knows what's on the right, but what's on the left could be something which is potentially, 4 or 5 decades old, and many of us were not probably even born at that point. So let me give you the answer. What you see on the left is actually the Apollo 11 Control Center of NASA. And why do I sort of show this photograph? This is because you'll be very surprised to know that the computational resources on the left side of this image are the same as that on the right side of the image. That is, that the iPhone now has a computing capability which was previously possible only in that big room with all these people. Of course, I'm not counting people as computational capacity, just the computers there. So now we are at a very remarkable point in history and time. But the problem is that when we design scientific instruments, we don't really leverage on this computational power. So the question is, what can we do? Like, can we make our computation, or can we make our procedure of taking information more computational centric? And this is what I try to do in my work. So like I said, now we have all these frontiers of science, and in these frontiers of science, the problem is that the sensors are reaching their limit, so we must do something. So if you take an ordinary camera, a 35 millimeter camera, you can see that it would be hard to go beyond 50 megapixels, because beyond 50 megapixels, it's the optics or the lens size, which the resolving power, which becomes a bottleneck, not necessarily 80 megapixels or 100 megapixels. So you see, to overcome these challenges, we must incorporate computational approaches. So what I try to do in my work is that I try to combine hardware and algorithms together. So the hardware knows how the algorithm is going to work. And there's also a part of the algorithm in the hardware itself. And that's what makes it unique. And said simply, the main goal is to sort of break popular limits that hold us back in traditional imaging and sort of sensing. So I can give you very quick examples of this without going into too many details. This is a very classic photo from MIT professor Edgerton. And what you see is a bullet piercing an apple. And what makes it quite a landmark result is that at that time, there was no technology that you could have allowed you to image at such a fast speed of exposure or phenomena. So how did he accomplish this? In fact, he used a very sophisticated method of timing a flash and a camera together, which allows you to get this kind of photo. And in fact, it is because of this landmark work that we see flash or a light in all the cameras these days. And that was how it started. So the question is that, can we take it to a next step of actually getting to the speed of light? Can we make cameras? So when I arrived at MIT, this was one of my first works that I co-designed with my friends. We designed a camera which could actually operate at the speed of light. Sort of what that means is that you can discern information at time scales which are so fast that typically normal cameras won't allow you to do. So this is one example where you can actually combine hardware and algorithms together, and it gives you much more than what classical hardware would give you. The second example is of bioimaging. So for instance, when you do microscopy, typically fluorescence lifetime imaging is a very important parameter for imaging, and it's very costly. So here what we did is we took off-the-shelf cameras like Microsoft Kinect, but then by changing the algorithms that are actually churning this data, we could show that you could pick out lifetimes, which was not so easily done before, or which was very expensive before. So this is a second example. Here's a third example. I'm very interested in photography. When I'm not working, I spend all of my time doing photography. So here, what we did is we tried to mix, again, a camera like Microsoft Kinect, and we could show that, in fact, you could cancel things like reflections of light. So most of us are taking photos from plane and train windows, and similarly, if we take photo of an object which is inside a glass cage, then we see all these reflections. But what you see here is essentially a technique to completely remove the reflection from the sensor. And finally, this is an example that is very close to my heart, which is where I'm able to devise a new kind of sensor with my collaborators. And the idea is that by measuring something that looks like noise, you can completely recover images which are much, much larger in dynamic range than what your sensor can natively capture. So this is something that I'm working very actively now. And this is much more mathematical than maybe hardware. So it's very interesting. So of course, all of this is very relevant. So because of this last project that I mentioned, I was recently awarded one of the largest prizes in UK, and it allows me to bring all these ideas, interdisciplinary ideas together. So this is more like a background. Now, one thing that I wanted to say is that the topic of this whole thing is rat race. And there are many interesting things happen when you don't participate in a rat race, because in rat race, the rules of the game are fixed. You know what to look for, you know how to go about it. And it just comes down to who's a tiny bit faster, or who's a tiny bit more strategic, or who's a tiny bit more capable in some way or the other. But when you don't do a rat race, then all kinds of things happen. So for instance, when I was studying in undergraduate, there was this book called Signals and Systems, written by Alan Oppenheim, who was a professor at who still is a professor at MIT. And what's interesting is that I was so fascinated by this topic that I started my own work during my undergraduate on signal processing. And then I started making new kinds of algorithms. And it actually goes back to the time in my undergraduate years when I started to work on these topics. And fast forward to many years later, this is one very interesting thing that I was invited to the regular group meetings of Professor Oppenheim, and they had a talk whose title was "Who is Ayush?" And I found it very interesting because you see, sitting back in the undergraduate times, I would have never imagined that such a day would come. But you will see later how to make these kinds of things happen more often, in the sense that how to get to. So let's see. There's a question somewhere. Sorry, I see a question from somebody, and
Ayush, we would handle it later. You can.
Okay. Oh, perfect. Right. So how do I get out of this question and answer?
You just minimize the screen.
Yes, for some reason I don't see my cursor because what's happening is, okay. Right. So okay. So I gave you a little bit of my background. What do I do? So you can see that some of these things are possibly not easily possible when you are on path to undergraduate, master's, PhD, and so on. So there are quite a few unique advantages of not being in a rat race, and but it all comes down to recognizing where does the rat race actually start. And for me, it happened quite early, even as early as I was in my school years. So I would like to briefly review what are the main kind of stops that I can now think of as a grown up. But even when I was a child, I could see that there was this common phenomena. So I grew up in Dehradun. It's a very, in India at least, it's quite popular for its schooling. And I would think that it was an ideal place to grow up because not very dense in population. And there was a lot of education institutes. So education was the primetime focus. And there, I realized very quickly that at school, there were only a few things that mattered. One was that in India, things are very competitive. So everybody tends to compare what are your grades, how you perform at a school, or what is your relative ranking. And then there's something like the board exam systems. You get good marks, you get to choose a good career, which could possibly be engineering or medical or stuff like that. And I was not cut out for any of this. So the way I saw this world was as follows. When you are young, you have no limits to think about things. You can walk wherever, you can do whatever, and so on. But as you start to grow, your parents, the society, environment, school teachers, everybody, they start drawing boundaries on your imagination. So essentially what happens is you get into this kind of a pentagram that I've drawn there, and the shaded region is essentially your constrained boundary. So that's all you are supposed to think. And what happened is that when I was growing up, I realized very quickly that I did not like going to school because there was something so mundane and boring about going to school that I could not really take it for I could not take it every week. So I used to spend a lot of time with myself, and I was very lucky in the way that my parents were very supportive. They did not really interfere so much with this kind of thought. So this reminds me of a very cool quote from Mark Twain, which says, "Don't let schooling interfere with your education." I think I'm not saying that this is the right thing for everybody, but I think when people are a bit imaginative, or at least I used to think that maybe I was imaginative, I think it worked out quite well. So I did my earliest school years in Dehradun. Okay, I had quite a few friends, and then it was very interesting to see that how everybody was thinking. So it gave me some perspective on my first steps towards identification of rat race. The next very interesting milestone came to my life when I was approaching middle school to high school. I started doing board exams, and I realized that there was a very systematic pattern in overcoming examinations, and I just did not like that at all. So I thought that exams, I could see how to do it, but I could also see how limited they were in what I wanted to do. But nonetheless, you see, when you grow up, as I mentioned in my abstract, you could possibly grow up in the Bay Area or maybe in the Greater London area, and you have access to a lot of top schools. So you have the life resources to actually succeed in one way or the other. But when you grow up in some other places, you don't have all these resources. So you have to make some kind of a change, and this change, you can think of it as an optimization. So for me, the optimization was that if I grew up in Dehradun, I could not have really expanded my life options. So I had to participate and get into an engineering college because I liked that stream of science, but it was then a question of how to accomplish. So of course, I decided to move to Kota for 2 years. Now, what you see in this picture is the very systematic way of how educational system works in Kota. The Times of India clipping says 18-hour study schedules, a brutal sorting system that segregates average students, no fee refund policies. Okay, so we don't care about the fee for now. What we care about is the 18-hour schedule and how you try to segregate people and filter. And if you think of how this thing is evolving, you can see from 2010 to 2015, this thing just doesn't stop. It just keeps going on and on and on. And this is like a classic example of rat race. Just do whatever you see people around you doing, and you hope to succeed that way. So I went to Kota. What I realized is that, of course, the intent was good. Everybody wanted, people to succeed. The teachers wanted people to succeed, but it was a very complicated method, not something that I would think would lead to direct accomplishments. The second thing that I did not really like about the system there was that they were not like true teachers, which would take B grade students and make them A+ students. I think that is hallmark of teaching, that you can take an average student and enrich them, that they can believe in themselves and they can do things that previously were not possible. The other aspect that I noted is that there was like this systematic way of cracking problems, which would give you the status of a genius if you did that in a very short time. And I did not quite think that that was the right way, but of course I was a minority back then. And when you are at high school, you don't even know what you're thinking is the right way or not, because your experiences are so limited. But growing, further, when I had a more diverse view of life and more exposure to different schooling systems, I realized that, okay, similar systems exist in Moscow or even in Paris at École Polytechnique, but they have a very systematic, they have a different approach. And I think somewhere that kind of approach is missing in our system, but I don't really blame the system so much, because we also are dealing with a density of population which is at a very different scale, and I can't think of a better solution. But here's what I took back from Kota. I worked really hard for 2 years, so it gave me a lot of work ethic, how to work without feeling hungry or like caring much about headaches or being distracted. So it builds a lot of focus and work ethic inside of you. It gives you a lot of competitive attitude. So you start to learn how to survive in competition, because competition can be a breakdown point for a lot of people. I saw that a lot in my neighboring in my surrounding. And the third thing is that you have to be determined to some extent. And if you're not, then things will happen which you don't like. So you have to be determined. So while I was going through all this sort of process, I realized that, okay, there was like, maybe I had potential to do something different. So I had this moment of, I think for me, it was a breakthrough moment. And this is something that I also explain to many of the students I meet wherever I am. So here's a classic problem. I would ask you to take a look at this for 20 seconds. It says that it's a very simple problem in mathematics, which is given at high school. You have an arithmetic progression and you are typically asked to prove this inequality. And for those who don't know what is arithmetic progression, what it means is that the terms are equally spaced. So 1, 2, 3, 4, these are equally spaced. 2, 4, 6, 8, these are equally spaced, and so on. So all it's saying is that if P, Q, and Rth terms are A, B, and C, then you have to prove this identity. I still give this question to a lot of my friends. I sometimes post it on Twitter and so on. So for me, the following was a breakthrough moment in life. When this question was presented, I could see that a lot of my friends were approaching this question from a very sort of strategic way, which was, like beaten like information into their minds, because this is how you solve problems. So what you do is you start with this kind of a strategy that you call the nth term is this, which is fairly simple. And then you just write these three equations, you try to manipulate, and then you try to prove that they are zero. And if you look at the solution, as you can see, some of my friends answered this question like that. There's a copy, there's a notebook excerpt from one of my friends who recently solved this. So you can see that there's just no intuition behind what is happening. And this is not how scientific problems are solved. To solve a scientific problem, you need a lot of intuition. So even back then, the way I saw this problem was very simple, like a geometric point of view. My point was that these 3 points lie on a line. So if the points lie on a line, then the area should be zero, right? You cannot have a triangle if the 3 points are on the same line, right? So if you substitute this formula to zero, you actually get the inequality. And here I have a little plot which shows that what I mean by the points lie on a line. But you see that here you don't even have to, you have to do minimal mental effort by just changing the perspective. And once I had this, once I had figured this out, I thought that, it's interesting that you change perspective and you can really give deep-rooted solutions to problems and with minimal effort. So the point is that why could not I continue with this way of life there? Well, because there was no time. Everything was fixed. It was a rat race. You had very specific constraints. You can't go beyond your own mental thoughts of, everything else was a luxury except for what was being taught. So once I realized this, I had this idea that, okay, probably I'm in the wrong sort of environment to do the kind of things that I would like to do. So this thing sort of sunk in my mind, and I realized that, okay, we need to change something. So what I did is that the realization was important that the circumstances were not favorable there. The second thing that came to my mind is that I need a more long-term plan, because I knew that how undergraduate educational system was, and probably it won't give me like the platform where I really wanted to solve problems like I do now. And then third thing, which was basically my parents, they made me realize that if this is what I wanted to do, then maybe spending extra year trying another luck is not really going to work out, because that doesn't really give you anything extra. So I realized all of this, and then I decided to move on. And as you know, that I went from my undergraduate to the JP Institute for two very simple reasons. One was that it was really close to my house, so very easily manageable. The second thing was that it was a relatively new school, so things were neat and sort of tidy, and I preferred this kind of environment. So I was very average at the undergraduate. I had like a average grade point average, not really trailblazing in any way. There was a different kind of rat race. You had to have a very high grade point average so that you could get a good job. Good job meant the job with a lot of money. And otherwise you had three options. So you could do job, or you could do MBA to get a better job, or you could do MS to get a fancier job outside of your country. So those were like the main options that were being exercised. I don't remember many people that I met were maybe enthusiastic or excited with something more, like something beyond all of these things, which I could completely understand, because probably I met a lot of people who came from Kota, and they were probably quite tired and exhausted with what they had gone through. And the other thing was that maybe the way we grow up, or the way our environment forces us, our minds become solidified by that time. So we probably don't really want to consider anything extra. But as you can see from that little excerpt over there, this is a question that I like to ask a lot of my friends, that what undergraduate did to you that other things probably could not have done. And well, you see, that's a brutally honest answer. I mean, no questions asked. So I don't know what to add over there. This is so you can see how people are smart. They're not like, so when they are in a rat race, they realize what they're doing, and they know how to sail through the extreme weather. So of course, this is my personal view of my own education. I don't say that everybody should have the same view, or this is because of that particular institute. I mean, ultimately you always take back something from wherever you are, no matter in a village or in a school or in a big school or in a city, it doesn't matter. But I'm saying that it's mostly the rat race view of life that we should be careful about. And for me, it wasn't working out, but I realized. So what did I do differently in my undergraduate? So I spent a lot of time outside of the undergraduate, of course, self-teaching myself. One thing I realized is that I had already gathered some confidence to solve problems. So I started to see if I could publish, and I started to publish. So I published about 8 papers in my undergraduate. Back in that time, it was still not so normal that undergraduates were publishing, but it gave me like some self-confidence of what I could do. It was even better because I was able to get, like I won some paper awards at some conferences. So I thought it was really like, it was really reinforcing my own belief that what I wanted to do, and it was going to work out. And then there was, of course, you know, in whatever circumstances you are, wherever on this planet I've seen, you will always have some peer pressure. So there was this point in time where everybody was applying for jobs and getting jobs, and I was the only like a sore thumb. I did not participate in any of the interviews, or I did not even like sign up for exams. So one fine day, I used to live, like I used to share my room with this person called Priyank, and he came and he told me that there's this company called Connexent coming over, and I should really try and you know, like, and I asked him like what was the format, because I was so unaware of how these things work. So anyway, I went there, and believe it or not, this was like a second moment in my undergraduate time where I thought that things paid off, because I was one of the 2 people who were who got this job offer, and the other person was the top, like somebody who had the best grade in our university, or I guess electronics. So my point was that I was trying to do things differently, but at some point I also realized that there was also reinforcement that I was not completely wrong. But as you may have seen, I eventually declined the job offer. I did it quite ahead in time just to make sure that nobody else gets left out. But I thought it was not really my thing. But when I appeared for the job interview, I could completely see that there was appreciation for how I was approaching things, and they did not necessarily think that my average grade was any limiting factor. In fact, maybe that's the reason that they decided to offer this job. So thanks to my friend who persuaded me and almost sort of challenged me that if I was good, I should have probably gotten a job. So I'm quite happy that I at least you know, did one thing right according to the rat race. So now, what happens for the first 22 years of your life, wherever you grow up on this planet, is you grow up educating yourself because you don't see a better suited system to see a way out of what you can do. So you are constrained in the sense that you make one choice after the other, which puts constraints on your life, and like where you go to school will decide what education you will get, what kind of foundation it will make. Where you go to undergraduate will decide your future job options. So if I'm studying, I mean, at least at the time I was studying, it wasn't the case that you studied engineering or electrical engineering and then you did medical sciences. I saw some of my friends did that in Boston, but this is not what we were used to thinking. So it was very clear to me that this is not my way of life. I would not be able to survive if I did things like this. So I decided to take a break. So what was my break like? So I did something which I later got to know that Professor Rainer Weiss from MIT also said this in his interview. And I find it very interesting because, I mean, I'm sure that he would have been saying this all these years, but it only came to me in 2017 when it was propagated in this interview. So I will play this and you can listen what he says.
Ayush, there is no sound here.
Sorry?
Volume.
How can I share my volume? Because I cannot really...
We cannot listen.
Right. I think it's because of my... Okay, so I would say that please look at the clip also has a written text. So focus on the text.
Okay.
Because the text is very important. I think, yeah. So please focus on the text. I'll play it again. Okay, so I will just briefly revise what he said. He said something about the apprenticeship system. He said that go to college if you like, but don't care about the courses so much. So what is he saying? He's not saying that walk on a high wire without a support. What he's saying is essentially that if you want to learn, this is a quote from Michael Jackson, by the way, that if you want to learn, you need to see a master at work, because that's how you learn. Just going and taking classes, or it's the same for dance and everything I've seen my friends do. Unless you are driven or you know what you're up to, you have to really see a master, and then you start getting those kinds of, you start imbibing those qualities. So of course, I'm sure that he must have said this since 60s, because this kind of thing comes as a vision, not really something suddenly that happens in your life. But I only got to know later. But actually, this is something that I had implemented in my own life, starting my undergraduate. So right after the undergraduate, I stopped doing what I should have been doing, which is apply for masters. And in fact, I applied for masters for one university to actually work with a particular professor, but then the university would not accept me because they said that they could not see my, my institution as one of the top ranking universities, which I thought was a very, very, very strange way to compare potential with university rank. But I was used to that if you want to do things out of the mold, these kind of things were very normal. So I did not take it very personally. I thought I'd still do what I want to do. So I believed in this apprenticeship system. I thought that I need to see how people work. So I did something. I took a first appointment at INRIA in France, which is the computer science sort of institute. And then while I was already at INRIA, I had another offer to be at NTU Singapore. And then I went to Hong Kong, and then I went to EPFL in Switzerland. All this happened in a course of two years or 3 years, something like that. What I realized is that I was extremely fortunate that, well, I would say in part fortunate, in part my own choices, that the people I wanted to work with, they were really the pioneers in what they did. And even today, they're very well known in what they do. So what I did is essentially, instead of trying to get into this sort of, this kind of a factory minting system, I started to look at life from the point of view of what can I learn? What is a scientific approach? How do you conduct professionally? How do you think about things? And I did not really care about my grades or where I was coming from. What I was focusing on is, let's say somebody came and gave me a lot of money one day and said that do something, I would have my brain in the right state of mind to actually execute a mission I have in my mind, and not really think about what to do and so on. So I had some ideas. It's just that I was not able to shape those ideas because I probably lacked the exposure or experience completely. So there are like a lot of things that as a scientist you must be able to do. One is how to communicate your results. If your communication is weak, people may not be able to make sense. And it's not important that people recognize your results as your results, but they should be able to recognize the usability. And sometimes this can help a lot. It can move a field, quite a few years ahead. So these things are very important, and this only works when you look at people. How they do it, and especially when they're experienced. And in fact, with experience also comes another thing, which people typically undermine, is experience of life. When you meet people who have been in quite a lot of situations which are complicated, conflicts, fame, and all these kinds of things, you need to keep in mind that how to keep a balanced approach to life, because you can very easily be sort of carried away by all these things. One of my friends once said that recognition is slavery, and this pretty much summarizes what it can be. So only when you work with people, you realize that there's a limitation to everything, and you need to have a very solid state of mind to be able to conduct. And I don't think this would have happened ever if I just jumped from my university to a big top school and just started to conduct myself. So what happened is I spent these stints working with the very best. I quickly learned about problems, what people were thinking about, how to approach, how people think. I used to see how they advise their students, how they conduct themselves. And then I thought that, okay, it was a bit too much going on in life. I was constantly moving, and although it was like a lot of information, but then there was also this point where I had to think about how to make use of this information. So I did a very complicated thing, apparently, according to my friends, which is I moved to Sudan in Africa. And this is because at the time, my father was working in oil industry, and because in 2011 the country was going under a split, Sudan. My father decided to relocate over there to facilitate his job, and I thought I should also move there and rethink about my own life. So I moved to Sudan for about 10 months. I used this time for two things. One is that I wanted to carefully understand what the data that I have gathered from all these experiences and how I can strengthen my own situation with this. The second thing that I realized that happened to me, which was quite good, is that, you see, how much you can see in this world also depends on what you have, what qualities you possess to see the world. It's like you see the same kind of mathematical problem at age 10, age 20, age 30, and it looks different at each iteration depending on what you know of the world. And same thing with understanding human beings. So it was the first time I could really see my parents as individuals and who they were and how they were. And this was very beautiful for me because I could really understand all of these things at a deeper level, having gone through the experiences of understanding other people and seeing how they were operating and so on. So this was something very unexpected. But I would again say that if your job or if your life gives you the opportunity, take some time to spend with your parents to see who actually they are. Because typically when we are with parents or our friends, we become in some kind of an autopilot mode, not thinking too much about what they have done for us or what they can do or how they think and so on. And the other thing that I really liked was I learned things about social service, which my mom was actively involved with. And I realized that it was, this was like the point or the seed where beyond my own goals of what I should be able to do or where should I be, I thought that, okay, there must be something larger, a larger cause for humanity, everything we do, because actually that's very important. It gives you more long-term satisfaction and it counts towards, like it's something that you can always rely on when you're working and you want to contribute to a larger sort of cause. So there was a different kind of rat race that I faced. I was going to like a lot of social events. So for example, I used to go to the grocery stores and I used to meet a lot of people who were diplomats, because Khartoum is a very international city and it's a house for many diplomats. So I used to meet a lot of people and eventually I became friends with, some people who were in their 40s and 50s. And at some point there was like this kind of underlying social pressure of what was I doing unemployed in a country like Sudan in the peak of my youth. And this was a question that I faced quite a few times. No one would ask it abruptly, but there was something like that. So anyway, I waited there for 10 months very patiently. And then one fine day, I decided that this is what I want to do in life. So I saw that there was one professor at MIT doing very interesting stuff with imaging, but in completely new ways. You may have seen this very famous TED talk, which is imaging at 1 trillion frames per second. So he made a camera that could actually image at the speed of light. And I wrote to him, not thinking much about any kind of admission or something. I just wrote to him casually asking if he would be interested in some collaboration, or because I thought I could really learn. I was very interested in photography myself, and I thought I could mix my experience of all these tricks or signal processing or mathematics related tricks that I'd learned. And so he wrote very favorably back, and it was very interesting and surprising. So I decided to pursue this. And when I pursued this line, I ended up landing in Boston. And in fact, it happened almost seamlessly. So you see, I was in Sudan for 10 months, 12 months, doing nothing. And suddenly this happened. So no way in life I could have found a different way to actually make this work out. And I don't know what he saw in me. I still never asked, but he must have seen something. And then I ended up going to MIT. And believe it or not, MIT was the only place where I applied. So it wasn't like I was bombarding applications everywhere. So I did that. And then fast forward, the first 2 years at MIT were fantastic. As you saw, we got like a lot of new things happening. And after 2 years, actually, I took another break from MIT for a semester. And this was because I realized that when I had landed there, I did all of this work. It was very fascinating, but I was thinking that how would it again fit back to my vision of being an independent scientist? Because until that point, what I was doing was with the generosity of ideas of my advisor. He is a very original creative thinker. He has probably contributed to a lot of significant ideas in science and engineering, but I wanted to be able to do this independently. So how could I do this potentially? And so I decided to come back home for another 6 months. And I thought very carefully about how should I plan a career. So I did that. I sat back home. I made some plans, and I thought that, okay, when I'm moving back to Boston, this is what I want to do for next 2-3 years. And this is how I'm going to approach my next steps in life. And then after this 6 months break, I went again to Boston in 2015, January of 2015. And then I finished in 2018, which was like about 3 years. And then at the end, I was quite independent in the sense that I had filed more than 10 patents. I had written some very important papers. I mean, with my collaborators, of course. But what was very important, and again, with the great vision of my advisor, was that he gave me the courage to actually not to be too much, suddenly too much of a specialist. He gave me the advice of trying diverse things. So I really tried my hand at applied mathematics, signal processing, optics, imaging, vision, all kinds of things. And I was able to publish top tier journal papers. And that gave me a lot of diversity, because it even helps me today when I apply for some research funding. This kind of interdisciplinarity is something very important that works in my favor. So now, now that I'm at Imperial College, I'm again, you never escape a rat race. So this is a different kind of rat race. If you're an early career scientist, there's something called tenure, which is that will you be given a permanent position or not? There's always this pressure to publish. How frequently are you publishing? Where are you publishing? You can't just like publish in like some unknown venues. You have to be really top ranking. And then the most important part of research is that you have a lot of freedom. So you can do essentially whatever you want, but it comes at a little cost, which is that research grants. If you are a good, well-funded researcher, really nobody really cares about what you work on. You can continue to do whatever, whenever. Nobody asks you to be at a particular time at some place and so on. So there's a lot of flexibility, but of course there's a rat race element to it. Now, like I said, when I was moving or thinking of making a career move to academia, I was very lucky to have met some venture capitalists who actually told me that think of early career professors as a startup CEO, because you have to make a team, you have to raise money, and it's the best time because you also are protected by some kind of a job security, which typically doesn't happen when you are in a startup. So he said that it was like a great sort of time to take a risk, and like I thought his advice was very useful. So I'm still trying to work on this. Okay, so I spent a lot of time on my background. I want to quickly summarize some very quick perspectives and lessons of what is generally applicable. Okay, so I would insist that although I'm talking from a very academic perspective, but these days the boundaries are very much blurred in the sense that there's no direct guideline that only if you, like I see a lot of rules of sports that can be applied to academia and also in businesses. So we'll come back to that. So when you start working, there's always this question of success versus ability. Success, the way I see it, is that when you go to a school like MIT or UC Berkeley or Harvard or Cambridge, Oxford, Imperial, you have a PhD and you're perceived to be you're perceived to be somebody who's very useful in Wall Street or finance or things like this. So success is success. Does it mean that you have a lot of money? Can you put your PhD education degree into money? Is that success? And a lot of people try to act that way, which is completely normal. And then there's the other question of ability, which is what's one's natural talent. Now, ability may not always lead to success, right? Because we have seen a lot of people, at least in growing up in India, you can play cricket forever, and it's not like you'll make it to the top 11 all the time. So there's always this optimization, and this optimization is somehow very much ingrained in how we function in our lives. And this is something that nobody can teach you, but what I'm going to present hopefully helps you rethink this optimization point of view. So if you think of it, there are three different formulas that work well. One is that you know what you want to do, so you have your list worked out. There's talent, there's work ethic, and there's fitness, mental or physical. And if you look at sports, it's very unique, because when you go out to play a sport, there's no other element than you yourself. Every time Roger Federer or somebody like Sachin Tendulkar goes out to play or went out to play, you see, it doesn't matter how rich they are or where do they eat or, you know, what are their circumstances. What they do there is what they do, and this cannot ever be exchanged. And that comes, so that's, for that, we know that there were other sort of people who did not manage to succeed in the way they did. And the real reason is that it comes down to managing your own sort of talent, work ethic, and fitness. Because if one of those three is taken away, you will probably find yourself stranded in the middle of nowhere. There's another formula from Thomas Edison, and that works well in a different scenario, where hard work is what helps you overcome all barriers. Now, hard work, I would say, in some way looks at the first list of formula, but from a different perspective. There's a Latin proverb called labor omnia vincit, which means that hard work wins it all. I think that is what Edison is trying to say. And then the third one is luck, experience, and ability. And I find this very useful for cases like J.K. Rowling, who wrote the Harry Potter series. And if you look at the early years, there was absolutely no sign of success. Many of the publishers had declined taking the manuscript for Harry Potter. But the element of luck is extremely important. There are so many things that happen in life which are beyond our control, and probably we will never be able to figure out what those things are, that we need to be very careful to be receptive to this luck flowing in. So when the luck is flowing in, we should be able to leverage on that. You can't be daydreaming at that point. So how to do that is also a challenge. But the first thing is to realize that this is the case. So we have those, so I listed those those categorical things where you could do this, but then you also have from time to time people like Yiting Zhang coming out from nowhere. So who's Yiting Zhang? Massachusetts, Boston is in Massachusetts, and Massachusetts is a part of New England in the United States on the East Coast. And in the same part, there's a University of New Hampshire. This university is fairly unknown. And this Chinese gentleman was a college level teacher of calculus. And in 2013, he made a breakthrough. He solved a problem, a very old problem about finding the gaps in prime numbers. And this completely came out as a surprise, because you can see from the quote from New Yorker over there, it says, unable to get an academic position, Zhang kept the books for a Subway franchise. So you can see the kind of long-term plan you need to have, and the kind of dedication you need to have to be able to do these things. So this doesn't fit any mold, but there's some element of belief here. And this again goes back to the fact that imagine if he was a participant to the whole rat race thing, where would have this taken him? So this is not just one example. There's another example. Gregory Perlman, here you can see this person. He solved one of the most fascinating problems in mathematics in 2006. He did not even publish them. They were published online on some preprint server called Archive. And he won a lot of prizes, including this $1 million prize from the Clay Math Institute. And there was a book written about Perlman. And I also managed to meet the author actually one day at MIT. And again, the question is, what makes these people the way they are? It's always fascinating, because they don't really fit the mold. They don't do things the way we are used to seeing things done. So the question is that, how can we make sense of these alternate forms of life? On one hand, we see coaching, resources, and fitness, which is prevalent in sport. And on the other hand, we see people like these who come out of nowhere and do unachievable feats. So at the end, we are all humans. So there must be some common point in these, some overlapping features in these different states of existence. Now, to take it further, if you look at many of the contributors, so this is again academic, but you can also think of Steve Jobs and Bill Gates and so on. You see, the start is not always spectacular. So Peter Higgs, he says, as he says in his own interview, that he was quite poor at physics. Stephen Smell, the mathematician who got a Fields Medal somewhere in the late 80s for solving one of the big problems. I met him last year. He was not very good at school in his early years. So he got the top prize in mathematics, but his grades were B's and C's. There are different examples. Yakov Sinai, right bottom, he trained some of the finest mathematicians of our contemporary times. And again, if you look at his own interviews, he doesn't claim that he had any special talent. So what rat race does is that it basically is a filter to kill out people suddenly, in the sense that if you are not a spectacular starter, it means that you're not enough. And I think that is not the right way to look at life at all. But again, that said, you also need to have a commitment to come all this long way, because if you don't, then you're neither in the rat race nor you're doing something outside of the rat race, you're just procrastinating. So in our times is that we have extreme competition everywhere at every facet of our life, from school to education to whatever you see, and it only gets worse with time. So here are some examples, like competitive science is competition ruining science, the Matthew effect in science, which is like the more famous people you work with, the more famous you become, and so on. So this is what competition brings. It will bring unnecessary effects which are unavoidable. What do you do? So here's a very recent paper from, I think, like 10 days back, the diversity innovation paradox in science. What it says is that although it is recognized in sciences that people from different areas or segregated areas actually bring more innovation, yet their recognition is not so common. And it's, in fact, on the other hand, it's discounted. So what it again means is that there's certain form of a prevalent rat race that runs in this line of work as well, where you have to be seen in a particular way, or you need to be doing things in a particular way to be able to succeed. So having identified the key sort of problems, like what is going on in your contemporary times, the reason I present this landscape of things is because when you are a student at an undergraduate university, it's very hard to see this complete picture of what is going on everywhere in one shot. In fact, I would say that even at grad student level, like even at PhD level, when I was doing things, many of these things were just hard to see, because it's a lot of, it's a landscape that runs a lot of, it's like learning the geography of the entire planet. It's not so easy. So, but it gives you an idea where the mountain peaks are, where the rivers are, and so on. So it gives you an idea. So the question is, how can you, if you want to plan something long-term, you need to be able to see the landscape that you're going to navigate. Otherwise, things will be very hard. So I would start with a simple way that if you want to sort of, if you want to make sense of your field, it could be a startup, it could be an idea, project idea, and so on, see how the field has evolved. So when sciences evolved, it started with Renaissance men. So these people were not like, in that time, they were not like scientists. They were doing whatever they thought was interesting. There was no research funding. They were sitting at home. They were doing what they could. And fast forward to early 1900s, we have sciences here, very well formalized, organized as physics, chemistry, mathematics, biology. In fact, what you see in this photo is remarkably your entire high school syllabus of science. You have physics, chemistry, mathematics, and biology. These are the people who did some of the pioneering works, and this is what we read now. So now what we have seen that from evolution, it was something very broad, and then it suddenly became too segregated, too categorized. So to give you an idea of how fast this is exploding, what you see, that equation over there, it's one of the most commonly used equations in engineering and mathematics. It's called the Cauchy-Schwarz inequality. The French mathematician Augustin Cauchy first found it in 1821, and then it took 8 years for another paper to show its utility. So you had like an 8-year gap in the 1800s. And what you see in the plot below is the plot of papers being posted every day on Archive, which is like a free, like an open source preprint server. And you can see that it has crossed a staggering 14,000 publications already in January of 2020. So by the time you reach, like in that 1 month, you're already hitting 14,000 publications. So you can see how fast it's exploding. And this is again, another symptom of rat race, because as scientists, you need to keep publishing and you need to look like you are productive, and otherwise people think that you're not good enough. And so what happened is, in the process of developing science, we started making these pillars: physics, chemistry, mathematics, biology. When we look at nature, clearly nature doesn't work that way. Nature has no fixed way of operating, that when photosynthesis is happening in a leaf, right now I'm doing physics and 5 minutes later I'll do chemistry. No, it doesn't work that way. It's how we learn topics. But that said, how we learn things is not how we should apply things. So think of engineering. Engineering is more like application of sciences. So what I've shown over there is I'm taking two different fields, biology or chemistry, or biology and physics. And you can see that when you make an algorithm, at the end, it's a very tertiary level operation, meaning that it's not fundamental anymore. So the question is that if you want to do something which has broad appeal, it should be fundamental. You cannot do something which is so narrow that it would only be influencing in that particular area. But that's for engineering, not for sciences. In sciences, you need to be more fundamental. But if you focus on engineering, so this is another trade-off that comes with rat race. How is that a trade-off coming from rat race? Well, think of these silos of physics, chemistry, mathematics, and biology. And suddenly now I come and tell you that deep learning is one of the most popular topics. There's a lot of money floating in deep learning. What will happen suddenly? A lot of people will start working on deep learning, which is that now they suddenly narrow down into that one area, completely missing out opportunities outside. So a good example is our contemporary times. Suddenly there has been this outbreak of the COVID, and now a lot of people are investing money for research in COVID. So now suddenly there has been a reorientation of research focus. And now our question is that, what about all the other things that we were doing before? Maybe there is something we missed out, which also solves the COVID problem as a larger problem of understanding infectious diseases in general, right? So categorization brings this problem, and it's not so easy to break free of it. So there's also this categorization in industry versus academia. In academia, the output is papers. In industry, the output is products. And again, depending on where you are, you need to make your bet. But one problem that I constantly see happening in academia is that if you started in 80s or 90s, you would have seen that when you entered the graduate school, the ceiling was not so high, meaning that you could still graduate, you can learn about the recent advances in the field, and you could contribute. That doesn't work anymore. The barrier to entry is so high that to be able to meaningfully contribute, you really need to spend a lot of time. And this is one of the reasons why I see that when people typically go to this consecutive chain of bachelor's, master's, PhD, postdoc, another postdoc, finding an academic job becomes really hard, because they don't realize that to contribute is something different than to be able to just learn the topic. And this is a contemporary problem. So again, if you want to contribute in sciences, or for example, even in a startup, you need some things. And the way I see this breakdown, it essentially comes down to three things. One is mentorship, that you need to be able to find somebody who can tailor make a program for you that takes into account your own abilities and your weaknesses, forces you to train in a particular way. And then of course you need a little bit of credibility, because in this world of rat race, which we can go around it, but still you need, if you are putting yourself in competition, you will be competing with the same rules, and therefore credibility is very important. So what do we need from mentorship? Well, the most important thing that we need is direction. And when I think of direction, the way I think of it is that when you go to, these days, Google Maps is everywhere. You go to a new country, you don't know how to go from A to B, you use GPS. And similarly, when you navigate a carrier, most of these people, there's no notion of GPS, or most people are not using it. And therefore, we need to really do that. So in fact, when I took a break from the educational system and started to do these different stints, what I was actually looking for was a method to navigate. And although I did not think of it as a GPS back then, but it was truly navigation. So when you have a good mentor, the first thing that happens is that your ideas get focused and shaped, because you see, if a person is sitting by themselves, they will have 20 million ideas. They will think of how can I mix A plus B, or how can I do this and that. But you need to really have a focus which actually proves or brings out the best of your idea. So having too many ideas can be also dangerous, and we need to avoid that. The second thing that one should realize is that if you're looking for a good mentor, like a world-class scientist, you need to see that they have time, patience, commitment, and most importantly, gift. If people don't have all these qualities, then you probably don't benefit, because you truly need a mixture of those. And of course, you have to be very fortunate to get a person who can do that. In my case, it just turned out that the people I worked with were so passionate as professors that they were truly like in different instances. So for example, in one of these Skype chat messages, you can see a professor is actually showing how to solve this problem, and it helps you navigate. Similarly, there's another professor there, a very renowned professor. You see the details with which they're writing how to restructure the paper, because it doesn't give good sense to the reader. There's another person who's actually showing how to solve this kind of a problem in Mathematica and so on. So you really need to have people who have time, patience, gift, and commitment. Otherwise, it just becomes like a regular transaction between two people that happens in a shop. And the easiest way to pay back is actually, once you have received all of these gifts from people, I think the noble way to pay back is to bring this to other people or students that you work with. Mentorship is also very closely tied to consultancy. And this is something that Steve Jobs left as an imprint at the MIT Sloan School of Management. And in this particular dialogue that he had in 1992, which is also available on YouTube, what is interesting is that he's basically suggesting that if you are looking for mentors, which in some ways are also consultants, you should be careful that they should be able to see through the end of their advice. Typically what happens is people give you an advice and they don't care what the outcome is. So there's a lack of responsibility. So it's only with this great responsibility they would be actually able to shape your course of life. And I think not everybody is doing that. So you have to be careful when you receive advice, and you also have to be very careful when you give advice, that do you have the quality to do that? It may be one thing to receive advice, but it may be a very different thing to actually give advices. And one thing that I learned was that the best advice is not to give. And it's true that if you're not asked for it, don't give it unnecessarily. So when I was growing up, all kinds of people were giving me advices, and it comes back to me that, it's our natural, maybe we want to contribute in one way or the other, but we have to do it responsibly. The other aspect that I see from mentorship, this could also be from parents, is that we have to avoid this thing called the Dunning-Kruger effect. And in this Dunning-Kruger effect, this is something that I see a lot happening everywhere. People read some WhatsApp messages and they suddenly think that now they know everything about COVID. And this is extremely dangerous. You cannot really operate long-term like this. You can't really read Wikipedia pages and think that, you understand the science of something. There are people who devote their lives trying to understand this thing, and there are some repercussions if you don't do it actively. So when you have a good mentor, they are able to actually put you on the track of what you understand and what you don't, because those boundaries are very important to gain clarity. It's only with knowing what you know, you have clarity. And in fact, this is not just operating in science or things like that. Even if in our ancient sort of spiritual literature, there's a lot of emphasis on looking inside and knowing what you know, because that is the real level of one's understanding. The other thing that I see is that the rat race forces a lot of us to publish very quickly, or even for startup, or even when giving ideas, we try to act in a bit of a haste. And sometimes I'm also a victim of this quality, that I try to act in a bit of haste. And it's very important to be able to rethink your positioning and to let things ripen a bit. You don't want to, like, I had a friend who likes to be a serial entrepreneur and do these things. But you see, the thing is that he's co-founder of 5 companies, but none of them work. So the question is, what is happening? And what is happening is that if the ideas don't ripe, you just jump from one tree to the other and it doesn't make sense. So one should try to be careful with that. So mastery is extremely important thing that again, we are somehow giving up on in these modern times, because if you go to a modern day university, we suddenly master 20 courses at one time. Now suddenly deep learning is a fad. So we want to do deep learning in like 6 months. And now we want to execute some methods that are online and want to write another paper. I think mastery is a very important thing. And here is a quote from the coach of this guy Perlman, who actually got one of the recipients of the Fields Medal, but he declined it. So he highlights something very important in that book, which is about single-minded devotion. So when a teacher inspires a single-minded devotion in the students, it lasts a lifetime. And this is something that we see is somehow failing in these modern times, because we lose track of our teachers even after 6 months or a year. We don't really care, or we don't really remember who taught us what. And that is partly because we don't have teachers who inspire this kind of devotion. Now, I'm not saying everybody is like that, but generally think of when is the last time you remember a teacher who inspired this kind of devotion, which you still execute in your day-to-day life. It doesn't happen so easily. So somewhere we need to rethink our system of how we are approaching education and how we are going about this. So my last stop is luck favors a prepared mind. And I want to say that luck plays a very important role. No matter how rational you are, there will always be chances or things that will happen beyond your control. And therefore luck is an extremely important parameter, and we should be open to it. This is a quote that comes from the French scientist Louis Pasteur. Pasteurization is the process of, preparing milk, which comes from this scientist. So luck favors a prepared mind. So the question is, can we prepare to be lucky? So now, before I go to luck favors a prepared mind, I want to say that Malcolm Gladwell has this topic of what makes a person unforgettable. For instance, Francis Bach was this famous musician, and he had a lot of contemporaries. But in general, we have this question of what makes certain people unforgettable versus certain other people. And if you think about it, we only remember people when there is a mixture of quantity and quality of work. If you just do one thing which is great, sometimes there is this phrase that is used, which is called one-trick pony. One-trick pony is a pony which only knows one thing, like one trick that they can perform. So in this particular text from Dean Simonton, who's a psychologist, he says that fecundity, which is how productive you are, is what distinguishes you from the others. So what actually he's arguing is that typically when people look at quality and quantity, they are seen as a trade-off or as opposing forces. But in fact, quantity can be a measure of quality in some ways. So that is very important. And this is what luck does to you. When you are lucky and you are prepared, you're time and time again in a situation which favors you in one way, which actually makes you much more productive, and hence your quantity sort of increases. So many of the researchers in contemporary times that I see, they have not only made a contribution to one area, but actually they're typically making diverse contributions. And I think of it, this is a point that I like to reinforce, that one should not really distinguish quantity and quality as two orthogonal parameters, but more as a measure of one and the other. So the question is that how to prepare to be lucky. So one thing that people often forget is that when you put an effort, the effort has a direction as well. Effort which goes in circle will only add to zero. And a classic example is maybe tennis. If you have read some of the works of, Roger Federer is a great example. And at this point in life, when I was living in Switzerland, I was very close to a place where Federer was actually a paying guest. And there are like a lot of stories about Roger Federer. So believe it or not, but according to his own friends, he was known to be an uncrowned prince because he possessed every possible talent of a champion, except that he was not winning. So the problem was that he had put a lot of effort, but it was only one of his South African coaches which actually showed him the ability to balance fitness with athleticism that brought him to this level of coaching, which he could really thereafter he could really master the art. So effort is a vector. Similarly, if you follow cricket, we know the example of the fantastic example of Sachin Tendulkar and Vinod Kambli. They both started at the same situation, same environment. In fact, Kambli was somehow better than Sachin. And of course, we shouldn't point out comparisons, but they're both public figures, so they have their life histories in front of us. So you can, if you read a bit, you will clearly see what I'm trying to say here, that effort is actually a directional thing. You can't just be like a bit lost about where you put the effort. So that's the first thing that I want to say. Sorry for the bullet. It should be one instead of two. The second thing is that comes from one of our Indian strategists, Chanakya, who said that we should learn from the mistakes of others because life is too long to make all of them. So I want to point out this other example from sports. What you see on the right is a match between Garry Kasparov and Vishwanathan Anand. And I was following chess for quite some time. And what I realized is this very intriguing personal story of Garry Kasparov, where when he goes to play Vishwanathan Anand in 1995, interestingly on 11th September, on the top of World Trade Center, they play about 8 or 9 matches, which are drawn because Vishwanathan Anand was quite formidable at that point, and Kasparov, on the other hand, was not able to break through his defenses. So what happened really is that Garry Kasparov decided to bring the guy in the middle photo, if you recognize, he's Vladimir Kramnik, to his team for making strategies, and they both decide to make action plan against Vishwanathan Anand, and then Kasparov in fact succeeds at the end of the game. After 15 games, I think he won 2, and the rest were draws. So he won. So in fact, from 1995 to 2000, Kasparov actually had a winning streak, and between 99 and 2000 specifically, his ratings were the best, all-time best ratings. Okay, so he was really the best in the game. He was invincible. But then he was supposed to face the same person, Vladimir Kramnik, that you see in the middle photo. And I like this story a lot because what really happened is that despite Garry Kasparov being at the peak of his career, he was really defeated by Kramnik, which was like a big surprise. So why did this happen? Well, what you see on the leftmost photo is the common coach to both of them. That is Mikhail Blotvinnik. He's a chess genius from the previous Soviet era. And what is incredible is that while all this time, Garry Kasparov was preparing against Vishwanathan Anand, Kramnik had the quality of taking notes of all the plans and where he would make mistakes, where he would have strengths, and so on. So Kramnik did what actually Chanakya had said, that if you learn from other people's mistakes, you can make a very intelligent effort of avoiding your own mistakes, and the net result is very clear. So in fact, we can all learn from other people's mistakes because not everybody makes the same mistake, but that is what we could benefit from, because when we see how people approach and what goes wrong, we can actually incorporate that into our own system. But typically, we are so self-obsessed or self-absorbed that we don't really care about we don't observe what other people are doing. And I think it's important. So the moment you start observing other people's mistakes, it gives you a very interesting perspective on how to recalibrate yourself, but you can also help others. And this is what I learned from advising students. So when you advise PhD students, they're at a point in life where there are too many uncertainties because they don't know what they will do next, and how will they plan. So you can really benefit from how they are seeing their perspective of life, and it brings a lot of gratification if your advices make help or can be of help to others. The third most important thing that I like about contributors, typically in all facets of life, is how they abstract ideas. So what is the meaning of abstraction of ideas? Well, typically when you are walking on a street or you hear about somebody else's accomplishment, we shut ourselves and we don't really think so much about what they're doing. But I think the key thing is that whenever something interesting is happening, try to see what is that common thing in that particular line of work. So if Steve Jobs is able to make a new phone, try to think what is the line of path that he's following that maybe in similar streak could help you. And this happens a lot. In fact, if you look at many mathematical innovations, for instance, calculus was somehow invented around at the same time from Newton and Leibniz. Similarly, there are like a lot of breakthroughs that happen similarly around the same time. And the thing is that a lot of people are abstracting ideas or cross-feeding ideas, and that only happens when you have the ability to think beyond or think beyond the horizon of what you see. So in particular, these three things put together, I think that they truly put you in a very formidable situation where you can really leverage from being lucky or prepared to be lucky. The last thing that I want to say is that when we choose things, there's always this matter of this question of, will we regret what we chose? And I think one of the things that we should really care about is that we should do things that are truly driven from inner satisfaction, because otherwise there's something called a burnout. So when we try to go against our own instincts, then there's a lot of burnout that can happen. And I see time and time again to people who basically took up jobs at Wall Street against their own inner satisfaction with something else. So if you are planning something, try to find it early that you can. So I would say that it's good enough time to actually close. So I would close it here. I would say that in closing, do something which has a larger cause, because it does. I mean, that's the ultimate thing. I mean, keeping everything to ourselves is not probably the best way to look at what we contribute to. So every time I've seen that when we are able to contribute to a larger cause, it does really come back in good ways. And this could be from simple things like helping your friends or students to helping whoever you can, because what I've seen is that it always comes back. So I would end it here, and I would end it by saying that there's this beautiful quote from Tomlin, which is, winner of a rat race is still a rat. So I hope that I've given you enough food for thought, and please feel free to put any questions you would like.
Yes,
Wonderful, wonderful. Yeah.
Yeah,
Yeah, Sonal, you are here. Please continue.
yes, I'm here. I'm here, sir. In fact, actually, Ayush, each and every slide of yours was inspiring and thought-provoking. But giving due regards to time and curiosity of participants,
Yes.
I'll quickly move to question answering bank.
Right, please, yes. Actually, sorry for having skipped, because I got too enthusiastic probably.
But yeah, really, actually, a lot of thoughts are going on even in my mind, and it was really inspiring talk. So we do have one question in the QA section that
Yes.
is, as you know, going out of a rat race is extremely challenging, and only high risk takers can venture to take the chances. And there might be moments of frustration and maybe 50% of chance of failure or regret. What is your advice to youth to have a backup plan? Do they need to have a plan B?
So I never had a plan B, and what that did, I mean, as maybe flamboyant or as stupid as it may sound, I never had a plan B, and not having a plan B was what was keeping me driven to actually accomplish what I wanted. So as you can see that, although I say I did not have a plan B, but you see that I took this 10 months off at home. I think that in modern times, it should be possible that people can go back home if they're willing to take the risk of what their social environment will make out of them. But yes, it is right that when you take, you see, if you don't take a high risk, the return will not be so high. So thinking of plan B, I don't really know what to say, because I don't believe in any plan B. It's a very dangerous, sorry to say, it's very dangerous, but that's how I see it.
Okay. There's one more question from Faculty of Mathematics in our university. Yes. He has really appreciated your talk, and he wants to ask that we have already introduced interdisciplinarity in mathematics courses in JK Lakshmipat University, and already started delivering by re-engineering the courses. What do you advise on mathematics courses and engineering programs?
Right. So actually, when we think about mathematical education, we need to keep in mind that what we mostly do is something called applied mathematics, which is how to apply mathematics rather than rather than actually learning about like how it's taught. So I think that in many universities, the trend that I see is there's always this course called mathematics for engineering. And I think what is not happening even today is there is this very segregated barrier between mathematics and engineering, in the sense that even some of my own, like there's this distinguishing boundary that if you are a mathematician, you are not engineer. If you are an engineer, you are not mathematician. For me, all of my collaborators right now are from mathematics, because I have the heart of a mathematician. I think I like to think like an engineer, but I'm not formally trained in mathematics, but I completely see the point that the gentleman is making there. I think this can only happen if the teachers start endorsing engineering sciences in mathematics. So if the teachers actually step outside of their zone, pick up problems from engineering and try to bring it back. Because if you look at the last 50 years, we have made a lot of progress in bringing mathematics to engineering. And that's where a lot of revolution has happened. But there has been very little backfeed. So there's not much feeding back, and people are trying, but I don't think it's easy. But I think education, the school education and university education is where this should start. And it's still not starting, because I think our curriculums, as I showed, the silos of science, they're too rigid. We are not willing to break free of it, because there's a certain level of discomfort of what may happen if, as teachers, we find ourselves in no man's land. And this is something that we should definitely address. We should gain clarity in ourselves. And I think this is what could help going forward. And I think it's people are aspiring to do world over, but you see, it's not so easy because our teachers are not doing that. We should go back to our middle school, where the same teacher could teach geography and the same teacher could teach some other subject. You see, they were a bit entrepreneurial. Our university professors are not so much of that kind. We need to do that.
Sure. One more question from Professor Gustav. He is from Department of EEE, and
Yes.
he is saying we are using Oppenheim's book this semester, among others, for our signals and control systems course. What can you say to inspire our students that are just learning the fundamentals of this area?
Right. I think one advice that I was given a few years back was that if you really want to understand a topic in engineering, like signals or control and so on, take something that exists, like the MPEG, the sound coding, or JPEG. JPEG is image compression. Image compression, and try to code it from end to end in your own program. Like, take something, it could be a simple microphone or it could be a simple camera. Take the image, put it all the way from where it's recorded to the JPEG compression and bring it back. In doing so, you would be able to accomplish much more than the book will ever teach you. Because you see, when you are driven by your own unique problems, it's like playing a video game. I've seen a lot of people who play video games, even at even the grown-ups. When you play a video game, you're always obsessed with how to solve this problem, and you think day and night about it. And at the same thing, when my mom is involved with this game Sudoku or something, the level of involvement is so high, it happens naturally because it's their own problem that they connect with. I think as an engineer, we need to connect with problems that we find exciting, because otherwise we will just flip the pages of that book, prepare for the exam, and give up. I teach a signals filter design class, and I know how it works. I mean, unless there's this mission or project, people don't want to do. They just want to pass the exam. So I would say distribute projects that could be very simple.
Thank you. Next question is from faculty of Institute of Design. Beautiful insights and a great session. He is sharing his views, and he wanted to know that if you are aware of any of the places that are working with the combination of AI and speculative design.
Ayush, this question is from your batchmate.
Yeah, I noticed. Yes, I noticed. Yes. Well, to be honest, I don't have a good answer to this because I'm not an AI person.
Sorry.
Sanjay?
Pardon?
Who is the batchmate, Sanjay?
Gaurav.
Gaurav was his batchmate in school. Gaurav, you are.
Okay.
Right. So unfortunately, I do not have a good answer. I can typically, I don't have a lot of answers, but I'm good at finding answers. So if given some time, I can find the answer to that question. But right now, nothing comes to my mind.
Okay. One more question from faculty of Triple E, that is Electrical and Electronics Engineering, Professor Devika Kataria. Did you anytime feel that you were making decisions for life yourself at an early age? Did you feel insecure anytime about making the decisions? Who do you consider the most in such situations?
Right. So I think this is the very important aspect that I'm only starting to recognize now, that parenting plays a very important role in things like this. You see, like I said, when I was not interested in going to school, my parents were pretty much open. They never forced any grades, or my like they did not really relate their social standing with my academic standing in school. You see, I see that happening a lot even today. So I think the reason I was not insecure, because I think my parents, maybe they gave me the impression that there was always like their safety procedure in the back of the mind. And at some point I became very repulsive to, like, I did not really care about failing. I thought I realized very sort of early in, as early as in high school, that people have very strange biases. Like, they think of inhale as breathing, but they don't think of how important it is to exhale. Similarly, success goes in circles with failure. What you call success today is going to be a failure tomorrow, because you have to iterate between the two steps. So I think, so the question is, did you feel insecure at any time? There's always insecurity. It's just human. You have, I mean, I had really strange moments when I did not know what will happen, or how something will turn out, or what will happen. But who did you consult the most in such situations? Well, it's a very important question. I think when I don't know what is happening, I try to democratize my decision. I have like a lot of friends I met in many different places. I think even for my academic decisions, I take consultancy from my friends who are non-academic, because I realize that, again, some qualities like leadership has nothing to do with your education. You're just that way. You can benefit from somebody else's view, and I think one should not hesitate one should not hesitate to. I want to say one thing which is very interesting in that aspect is that what I've seen is sometimes just talking to people clears your mind so much. Like, when I have some new idea, I just talk to students, what do they think? And just explaining to them, I realize what I need to do. And then I just cut, and they don't understand why did I just cut short. But talk, democratize, never think you are enough. I mean, not in a bad way that you think that you are nobody, but you will be insecure. It is part and parcel of life. I've met quite a few. I've met people from the movie industry. I've met I've met quite a few people. Everybody is insecure. I don't know one person who's not insecure. Actually, I think the only time you're insecure is when you stop breathing. So
okay, let us handle two more questions. I think we should give
yes,
importance to students as well. This is
yeah.
BTech student. Again, he is actually, it's a counter question to the answer of your first question regarding having
Yes.
plan B. That
Yes.
as we all know that there are 1% success stories along with 99% of unsuccessful stories, which we never come to know about. So
Yes.
all successful people say that they didn't had any plan B.
Yes.
And
Yes.
so do you think that actually, what is your final say on that? Are the people who are
So
unsuccessful wrong about having plan B?
no, they're not. I think my fundamental view is that the moment you call something success, you have actually constrained yourself. You have tied yourself to something. Life is not meant to be like our great, like we have a great heritage of spiritual leaders. If you read a little bit, you'll realize that there's nothing called success. Is just a perception of our prized possession. There's no. So I think that the moment we think that, oh, only if by the age of 25 I am like Steve Jobs and I have this amount of money, I'm successful, I think that model is very dangerous. And then as you know that, like, so the question is that there are only 1% success stories. I don't think there are 1% success stories. I think every person is accomplishing something on a day-to-day basis. It's just that our perception of that is so small that we don't count it as success. I mean, we have this romantic idea of eulogizing something which is only so much beyond ourselves that we will call it success, right? That's what we call success. Yeah, I can give you an example of what I call success. 3 days back, I could reproduce cooking potatoes exactly like my mom would. For me, this is success, really. I don't think of, but maybe for my friends, it may be something ridiculous. So I think the obsession is not right. The moment you release this obsession, this 1% and 99% thing will go. You will not think anymore about what is this thing. And I think that's the right way to think of it. You see, I was not successful in my school or thing because I was sometimes on the top of class, but mostly I was not. And I think a lot of people made me believe as I was not successful. But I never thought of it that way. But I think it's very hard to say, you see, because your question forces me to go to a territory which is not natural. It's not my natural landscape. So I don't know what to say, but I would say don't think about success and failure so easily or so early in life. So sorry, maybe my answer is not very clear, but I don't know what to say.
There's one more question from one girl. She wants to know something about taking admissions in post-graduation in USA in MBA. She has already, although actually directly asked comparison between two universities, but let me actually summarize her question with saying that whether actually as a fresher they should invest a good amount in doing post-graduation directly, or should they have 2-3 years experience and move there? And any pinpointed scholarship ways of getting the scholarships?
Okay, so I have, I would like to say that my feeling is MBA is not the right thing to do in these modern times, because you have to keep in mind where will you force your trajectory. You see, in startups, people who are starting the startup like to be MBAs already, like they like to act as MBAs already. 10 years back, I would have definitely told you that spend money, go to Harvard, or spend money, go to Wharton, go to a top school, get that one line on your CV that you did your MBA there. That would give you a big investment, big return on your investment. Now, I don't think, I'm afraid MBA is not the right thing to do. But anyway, if you want to go to a top university, and be very careful on how the brand matches the job. I think money recovery is possible. Money recovery is easily possible with MBA. We just have to make sure that you cut through the right thing. If you go to not a top tier school, I would not say spending that money is any good. Then just join a startup or something. Yeah.
So thank you so much. And over to Sanjay sir. Sanjay sir.
Wonderful, extremely great. If we were sitting in an auditorium, I would have called the audience to give you a standing ovation.
No. I think that would be a bit. No, I think the real fun would have been had it been face to face. Because the thing is that although I use these slides, but these slides, I don't know what do they like. I don't think they do the right communication, because I think they are just to support my thoughts. But it's much more easier if you can interactively talk to people. Because imagine if this entire talk was these question and answers, it would be much more exciting.
Surely, right? but the talk has really come out very, very well. It was with a great purpose. It had a great content, wonderful insights.
Thank you.
And you are a wonderful storyteller. Great storyteller. Okay, great content, great insight, and wonderful story. Wonderful.
Thanks.
I have a question.
Yes, please. Yes.
Can education develop intuition?
I think we have to ask the question of what is education then? Like, how do you define education? Because if you look at our times of the rulers, the Chandragupta Maurya times and so on, they did not have education, but they had great intuition to rule. But then when I say education, in the sense that they did not know the laws of gravity, but they knew what works. So I think that qualities like intuition, leadership, I think a large element of this one is born with. What education does is that it sharpens your ability to reach, to make it more articulate. So if I learn formally about something, I've noticed in my own lifetime that there's things that I just knew. It's just that learning that stream of science or engineering made me articulate it better. and it's the same thing in this talk. Maybe I'm not articulating myself in the most effective way, but I think intuition in itself, some people are just born with it, right?
So did your
that's
education
how
help you to develop your intuition at various places, school, college, UG, PG, MIT? Did formal education help development of intuition, formal education?
I don't think so. I don't know. My answer is no, because I saw, I mean, what I learned by seeing people was much more important. Like, and I still can't really, I have a problem putting this down to words, because now I'm advising students and I still don't know how to, when I want to communicate the same things, I can't. And I realize that some students are very intuitive, and it has nothing to do with what they have studied or with whom. They just get it, it's their state of operation. Same with businessmen. Some people are just like that. They don't have to, they don't have to have this education. So I don't know, maybe if you ask me in 10 years when I have become a more experienced educator, my answer would change. But I don't, in my own understanding, what I've learned is that you just see people and you realize that a lot of, yes, please.
If Sanjay and Sonal would permit me, just one, when you were talking about responding to the question on plan B, plan something, what we generally teach, you have plan A and give 100% to it. Suppose, God forbid, it doesn't materialize, plan B will always be there. So just don't start your plan A with plan B. That's what we try to say and share, and that's what we believe in. And that goes in line with what you also suggested. Give your 100% to what your plan is. That was just on my bit.
I have a little bit of, the way I see it is that actually I do not, maybe my thoughts would again change in 10 years after I have advised enough PhD students. But my point of view is that I do not work in life with plan B. Yeah, I don't have, I like, even when I wake up, I don't think of what if this did not work out. I just put everything, and I wait till it crashes completely. And it has happened. You see, it has happened. I mean, I must tell you a little story here in very short 30-second slot. My obsession was that when I was an undergraduate, I'd read a few papers from a gentleman in Switzerland, and he's a leading figure now he was a leading figure back then. I was obsessed that I would like to do a PhD there. I went there, I got a PhD offer. I started my PhD, and I realized how limited I was in my own short cycle of life. Like, I realized that it was, and it's very intriguing that when you're a young person and you imagine everything to be that one thing you want, and you get it, and you realize that it's not what you want. You have like a very strange. So sometimes you need to have a plan B, because your plan A is not the right plan.
All right, that was on it. And the other point I was wanting to just seek a little bit of clarification. When you talked about some attributes of a good mentor, I heard you talking about something like gift. Could you just
Yes.
let me know in another 10 seconds what that meant?
So as you know, we are all born very differently. What that means is that our capacities and our abilities to see things are also very different. So it's very natural that some people, even when they are 30 or 40, they are maybe years ahead in how they think. And that is, to me, a gift.
All right.
Right. So if you find somebody like that.
Gaurav, you need to unmute yourself because you are excited to have a word with your batchmate. Gaurav, you unmute yourself.
Not audible.
You're not audible.
Not audible.
No,
now, am I audible, sir?
Yes.
Okay. The setting was at the wrong microphone settings. I just wanted to say actually a big thanks to everyone who made this webinar happen, because personally I have not met Ayush at the school, and also we were in different sections, right? I was in commerce, he was in. But so it's amazing how at different point of time and as a surprise, people can meet together. And I also resonate with him at many levels. I didn't think he would have hated school, because I carry that personal feeling within me. And I thought that could come from people that might not come from a science section in a way.
No.
But yeah, but we both have a similar thought of working around education, or that's will there. So yeah, I just wanted to thank the departments who made this talk happen, and it's been amazing. Nice to meet with you again.
Thank you once again, Ayush, on behalf of all of us. Sonal.
Yes.
Yeah, so thank you, Ayush, for wonderful talk. Thank you, Sanjay sir, for connecting us with Ayush. This has been really a wonderful talk. Thank you, Rana sir, Gaurav, and all the attendees who attended this session. And this session would be there live on later on our Facebook, JKLU Facebook page. So anybody wants to go or have this session again and have a relook at it, please actually visit our Facebook page.
Great.
Thank you so much.
Great. Thank you so much.
Thank you.
Bye, Ayush.
Bye. Good day. Bye.